guest needs no introduction. Matter of fact, I'll just walk off right now. Hi, how are you? You guys already know Lee Holmes, one of the most amazing guys. He's done a lot of help for a lot of us with scripting and automation from his books and as a dev here. So ladies and gentlemen, welcome Lee Holmes.
All right, so I'm Lee Holmes. If we haven't met before, it's awesome to see all you guys come here, drink from the fire hose. So just a little bit about me. I discovered PowerShell a few weeks ago. I think it's a great new thing. So I thought I'd share a little bit of what I've learned. So how many of you here, this is going to be a gradually going down, have visited a web page? All right, I have that. How about Invoke web request? How many have checked out the raw headers stuff in Invoke web request? Still getting pretty good. So whenever we're visiting a web page, our computers are doing a ridiculous amount of stuff. Now, the more we know about that ridiculous amount of stuff, the more we can script it, the more we can do, the more efficient we can be with things that don't want to cooperate. Now, you've probably had an experience when you've used Invoke web request. You did something that worked great in IE, but then when you went to script it, that didn't work at all. And we'll take a look at some of the reasons that could possibly be. Sometimes that is projection issues. So I need to stop walking around and instead keep on typing. I think we got it. Okay. So now,
Push the wrong button.
I did. All right, so that was the only slide, so we don't we're going. Now, here's where it gets cool. So we got everybody here has been to PowerShell.org, right?
Mm-hmm.
What the hell is happening when we visit this? Now, the way that so our goal today is to step back a little bit. Our goal today is to figure out, hey, here's a bunch of things that the browser is doing. We've got Invoke web request, that's doing some different things. Sometimes you have you need to talk to a network switch, and they have some sort of telnet interface. They don't give you commandlets. So what are some of the ways that you can start to manage these things, work with these things, and interact with these things when that sort of out-of-box experience isn't there? Now, when you're starting to deal with web pages, one of the things that we, of course, added in PowerShell. Can everybody see that okay?
That needs to be a little bit bigger. I'm old.
So we also of course have Invoke web request. Now, this is simulating a bunch of what your browser does. And actually, when you access the parsed HTML property of Invoke Web Request, we are actually literally using the Internet Explorer engine to go off and parse all that HTML that we just downloaded. Now, sometimes you might use Invoke Web Request, and you've got a situation where you're receiving content. You started Invoke Web Request. So you can see here I've got the different links from PowerShell.org. All right, so that worked out great. But sometimes you'll take an Invoke Web Request, and then you'll go off and try to use a web session to, let's say, script a login to another site, or to try to, find out what your utility bill is by entering your usernames and passwords and stuff. So there are tons of examples out there of how to do logins and access the forms and use those for new sessions. So I'm not going to go into that here. But what you end up getting is, let's pretend we've gone into PowerShell.org, and now you want to do a login, and we're just going to pretend here that we're doing a search instead. So you search for something hello. Now in the background, IE is sending gobs and gobs of data to PowerShell.org, and most of that data is happening behind the scenes. There's a conversation between your browser and the web server. They're setting cookies. They're trying to remember who you are by remembering some sort of session information, and all that stuff is being passed. Very little of that happens up here in the URL. Now, Invoke Web Request works great just very simply when you're able to copy this URL and paste it into another URL. But what if that doesn't work okay? So one of my favorite ways to start investigating what is actually happening here is Internet Explorer and Chrome and Firefox have different versions of developer tools. So IE has, they call them the F12 developer tools, and not a big surprise about how to get into them. F12. So these are your Power Developer tools, and if you haven't seen these are a really great way to understand what IE is doing behind the scenes. Firefox has Firebug, and Chrome has the developer tools as well. Now, I showed you a little bit back there about kind of accessing the links. Now, see how IE is able to be so intelligent about bucketizing these things? It's able to detect, what is the head and the body and the tables and all this kind of stuff. Now, that's where the parsed HTML bit out of Invoke Web Request is really helpful. But we're going to go deeper here. This network tab is the one that shows the true magic that IE is doing. It actually shows the conversation between IE and the server that you're talking to. So let's try another request to PowerShell.org. We're going to do this hello search again, but now let's see what's happening in that conversation between IE and the web server. So we'll start capturing. Click search. Same as before, but now IE has given us a huge amount of information. Like all these rows are chats back and forth between IE and the web browser, and the web server. So in general, what happens, this very first URL, you can see here, this request, that was the actual get. So you saw that stuff in the URL, ? hello. That's the main part of the request. But in addition to all that, IE sent a bunch of sort of meta information about this request. So it says, for example, I understand XHTML. Here's where I came from, the refer field. Here's the languages that I can accept, and a bunch of properties that are like that. Now you can see when this cookie and this refer, sometimes you'll get a website where it turns out they actually depend on the refer as some sort of security mechanism. So you go to make a request on your energy bill website, And they, as a security thing, say, well, let's make sure that it was referred to by the previous page. So sometimes they'll do that, and you'll see that that's one of the things that they're doing. They also sometimes check out like the user agent, where they'll say, hey, we're only going to accept user agents that are like IE or whatever. So this is a great way to start investigating the browser-server interaction. Now, once you start getting more advanced than that, one of the things, for example, this doesn't, it shows things in their groups. You're not actually seeing, so it's showing the headers here, but you're not actually seeing the raw content as it traverses across the network. This has already been sort of intercepted and parsed a little bit. Now, the next thing that's really helpful, once you want to start getting down a little bit, is a tool called Fiddler. So it's a free tool out there on fiddler2.com, and it's really designed as a deeper PowerShell tool, power tool when you're starting to work against websites. Now this is the main view you get. Now let's take a look. If I do this search again, now if Fiddler is intercepting this, rather than Internet Explorer, this is actually this Fiddler tool. Now here's a closer look at everything that's been done. So you can see all of the the headers. Now here's a good view that I like to look at when you're saying what actually happened when I made that request. And you can see here there's a big chunk of the raw headers. So what happened here is Internet Explorer made a connection to PowerShell.org on port 80. And if you've ever used the TCP client class in PowerShell, you can actually do this yourself. It made a connection, and this is literally the text that it dumped into that connection. And then you can also see here is the raw response. So I've got a request here to PowerShell.org, and the raw response says, hey, that was an OK request. You heard about different server error codes, 500 and 404. Well, that's where that's coming from. And then it tells you, the last time it was updated, so the browsers can do some smart caching. Now this is where you can start to say, well, hey, I know that this request worked just fine when I used IE. Why didn't it work with Invoke Web Request, for example? Because Invoke Web Request, in addition, does let you, instead of just doing a direct request, it also lets you do things like pack in additional headers or set your user agent. So sometimes those things are going to be broken, and you can fix them using those parameters. So now let's take a look at what happens when we do Invoke Web Request. So now this is happening through PowerShell. One thing you'll notice immediately is that this is 2 requests. We made 1 request. Now, this is where using the power of the commandlet is great instead of just using the web client class. So you'll notice here that we made that initial request at the top of the header, the get. We said, give us your home page. And then down in the response, PowerShell.org said, no, that's not the right place to get it. It's been moved, and it gives you the new URL and everything else. So Invoke Web Request saw that, automatically followed the redirect. And then here's all the information that we sent in that redirect. But you'll notice here, so even we got a cookie. If you've ever tried to do direct scripting against a port, things like, hey, in this first request, it told us to remember a cookie. The second request, now we have to start giving that cookie back. That's a very, very complicated thing. An invoke web request makes that really simple. But probably what you'll notice the most here is that we sent 4 lines of information in that request. So you'll see here we sent the user agent we actually sent that it's Windows PowerShell 3.0. Now if you've got one of those sites that says, well, hey, you can't visit us with old outdated browsers, you can only visit us with like IE or Chrome or Firefox, we have a PS user agent class in PowerShell that lets you say, well, just act like Firefox or Chrome or IE for the duration of this request. Now, if this isn't working, what you can start to do is, hey, there was these 4 headers. You can go back to Fiddler, and Fiddler lets you replicate requests. So you can take one of those old requests, drag it into this feature called the request builder, and then you can kind of keep on hacking out lines until you get the errors. And then once you get those errors, then what you can do is bring those into Invoke Web. Once you figured out what caused the error, right? Hey, I ditched my user agent and it stopped working. Then you can add in the different user agents into your Invoke Web Request headers. So the web is just this wild world of really complicated people behind really complicated web servers and all that kind of stuff. And eventually, sort of getting down to this advanced network level is a really important skill to have when you're trying to do advanced network scripting with Invoke Web Requests. Now, one of the things you'll notice about the IE developer tools and with Fiddler 2 is that they're very, very customized to HTTP. So they're very, very strong and focused on dealing with making web requests and whatever else. Now, I had mentioned when you are taking a look at this, this is all being sent directly across the wire. So anybody who is on the same wireless network right now got to see all this stuff coming across the wire. But you can, now, that's why they have SSL. So let's turn on capturing again, and we can go to the SSL version of the Microsoft homepage. Now, this is what actually happens across the wire when you're doing SSL. So we make, initially, the browser, whatever, makes a connect request. And it still has a couple of things like your user agent and the request. Now, this down here is kind of here in past is Fiddler helping to interpret some of that SSL request. So basically, the browser and the web server agree that we're going to now transition to SSL, and then there's a bunch of certificates being exchanged. Now you can actually see here are the SSL algorithms that the browser understands. Here's who I expect it to connect to, and then coming back, the server sends a certificate, and so this stuff here, you can see that no longer did I have the URL, so I don't actually know if I'm sniffing on somebody's wireless network, you don't have all that text. So there's a big difference between sort of plain text protocols and these encrypted protocols. And so this is why you've even got versions of Firefox which are just designed to sit there, sniff on the network. When they see plain text, you saw back there, there's a bunch of cookies being transmitted. A lot of times, those cookies get used to identify you uniquely to the website. So if you steal somebody's cookies, you are that person to that website. So there's versions of Firefox that will steal all that stuff and say, hey, we found a cookie for somebody connected to Facebook. Do you want to be that person? So that's kind of the importance there about using encrypted protocols. But all this stuff is HTTP and not FTP or anything else. Now people talk about the danger of using unencrypted protocols, and really what does that mean? So let's take an example here. You may have heard of netmon from PowerShell. So that's being replaced with Message Analyzer. Now this is actually the exact same tool that Microsoft uses. We ship a lot of protocol documentation, and this is the same tool that Microsoft uses to help ensure that that protocol documentation is correct. Now, if you're doing any unencrypted communication that you care about right now, stop. Now, what we're going to do is start up a capture on an FTP session. Now, for this, I usually use the firewall provider. That's a very high enough a stack that it gets useful information. So now you do this all the time, probably updating your websites or whatever. Now you can't see what I'm typing, so it's really secret here. So you didn't see that. Oh, incorrect, but that's fine. Now that was security, right? Like you didn't see that password, I logged in, it's awesome. Now, this is actually the data. So we just Message Analyzer parsed 2,000 different packets going on this LAN as this all happened. Now what you can do is do things like this. I'm going to filter on FTP connections. Apply this filter. So you see here, I'm making requests back and forth against some FTP site. Now what happens there? You remember seeing that? FTP came in. Here's the FTP protocol itself. So the FTP application said, hey, who are you? We gave our username, and the FTP protocol says, well, the way that you actually do that across the network is you say user space, and then the username. And then as for the password, we typed it, you didn't see that. So anybody who was on the wireless network just now had the ability to see this password going across the wire. And of course, we got the response that it was incorrect. Now hey, what if you don't have the ability to do FTP? That filtering on FTP was pretty cool. What if you don't have a thing and you don't even know which protocol you're doing? Now this filter view, if you use snippets in the IIC, a great quick shortcut way to get access to some PowerShell snippets. They also have a filtering language. It's kind of complicated. I forget it all the time. So you can go into the library and say, well, what if I'm looking for just anything where the packet itself contains paths. Now this could have been HTTP or FTP. Turns out that I was restricted when I did that FTP just now, but it just did a search against all the packets that I captured and did, hey, here's a password required, and then here's the password that I sent. So looking at all these packets now that are with the word password in it, and that's kind of demonstrating the importance of encrypted protocols because you're in a coffee shop, you don't want to be doing management, for example. So WSMan, PowerShell remoting, is encrypted by default. We make it very, very hard for you to make a connection where this kind of thing might happen. Now, I showed you a little bit before how Fiddler had that great header view and that raw view when talking to another machine. Now here's an example of sort of just, this is a very handy way to do things. Here's an example of I just copied and pasted that out of Fiddler at one point. Now this is a TCP request. And there's a script up on Posh Code and the PowerShell cookbook and pretty much wherever you want to find it, called send TCP requests. So it's also in the PowerShell cookbook. Now you might want to say, you can say get content. Now this is an example of doing raw TCP scripting. So when you think about it, I had mentioned that when you're making a connection to a website, this is just opening up a socket to port 80 on another machine somewhere. Now inside that socket, you're just ramming down a bunch of data. Send TCP request will just take a random text file and kind of jam it down that same pipe. Now here's an interesting example. So I just made that connection. And this does not look like HTML. I make mistakes, but this is not looking like HTML. And what you see is the server here actually responded that, hey, that was okay, and I encoded the content for you. This is actually Gzipped and compressed. And so that just makes the connection faster between you and that machine. It's all compressed on that side, gets sent to you, and then your browser says, hey, I understood how to decompress this, so I'll decompress it. And actually, the reason why it did that is because in that TCP request itself, I said, I understand how to deal with things that are gzipped. So what happens if I say I don't know how to do that? So there's all that HTML that it had previously sent me encrypted, or not encrypted, but compressed. Now you could have taken this out of Fiddler, or you could have also done this as out of the network monitor. You want to connect to it. You've got some tool that is really connects up to a machine, and it does some stuff and gets your results back, but you want to be able to do that through PowerShell. This kind of thing is an approach you can make. So you can use, if it's a plain text protocol, and most devices use plain text. If you're just connecting up to a router, a lot of times it's Telnet or something else. And so you can use this form of management to start to script these things that otherwise have sort of isolated you out. Now there's an additional thing. So we played around with the message analyzer. We've extracted out information here. Now what I'll show you a little bit about how the TCP request. So here's a great example of a script where you might need this in PowerShell. So imagine you've got a mobile phone that's kind of accessing your mail server. And then you've also got your desktop clients, and they're accessing your mail server. So when you have two types of machines partying on the same mailbox, if you're just using regular SMTP servers, they don't party well together. You end up having to if you like retrieve messages and they get stored in the local mailbox, then they're gone from the remote server. Now, if you use IMAP, and like, so you're using Outlook.com or Exchange, IMAP is meant to be like, hey, all this stuff is stored server-side permanently. Your clients, all they do is connect up and see what's been read and all that kind of stuff. So SMTP is not that way. So I ran into this issue where I still wanted to have a copy of my mailbox on my phone, but I didn't want it to be deleting items or taking off items that I really wanted to be in my Outlook mailbox. Now this is just an example of, so when you're accessing a mailbox, it's very similar to FTP that you saw, where what you do is you make a connection up to a different port rather than the FTP port. And you say, here's my username, here's my password. This stat command will say how many messages do I have, and then quit. Now here's an example of, well, I got there and I found out how many messages I had. Now I want to start retrieving certain messages and making sure, are they doing the right? So I've got a username, password, again in plain text. This is all just straight up scripting against that network port. And kind of the output of this script was I was able to synchronize a brand new mailbox and a brand new SMTP mailbox where I didn't care if I deleted messages and stuff with sort of my master one, just by going off and doing this network scripting. So there wasn't any tool to do this, but it was really easy to do through PowerShell and TCP scripting. And another good example is if you've ever had sort of Outlook and a Mac talking to the same IMAP server, when you delete something on the Mac, it marks it as deleted, but there's an additional step in IMAP which is called expunge, which means just actually remove it from the mailbox. So Outlook will treat something as read, but unless it's been expunged, it'll still show up there, even though you thought for sure that you had deleted it on your Mac or something else. So that is you search around online, you find people complaining about this. Some people make some magic C# app that does this. That turned into just a very simple 5-line script, connect up to the IMAP port, give the username and password, run that expunge command, and exit. So it was just a very, very quick PowerShell script to do the same thing that people are literally selling professional tools to do. Now, here's an example. We've done like basic TCP scripting, well, advanced TCP scripting with PowerShell. But it's possible to even get deeper than that. If you want to start hacking on bits and bytes, Windows has a way. So you saw that I showed you in Message Analyzer how to start a capture, kind of dig through some stuff. But what if you wanted to do some PowerShell scripting against this stuff? They've got a big plans. They talk about on their blog about having a managed interface to Message Analyzer. And they talk about having a plugin model and stuff. And I don't know how that stuff works. But what you do see here, let's take a look at this packet. This is the data down here, this message data. This is literally a packet of data that went from my computer to another computer. There's some stuff I recognize. I would rather not see that in the password line, but there's some stuff I recognize. And then what does this stuff mean? You see these things in network captures, or you see these things, just open question what it means. So let's take a look. Now, one of the neat things about Windows Server since, I think it's 2008 R2, Inbox, there is a network packet capture utility. So you don't need to have Message Analyzer or Netmon or any of the open source packet capture tools. So netsh, trace, start, and then you give it a scenario. internet client capture equals yes. Now, this is built into Windows, and what it does, the scenarios, there's a bunch of, if you've heard of ETW or event tracing for Windows, there's a bunch of these things instrumented all through the stack that tell you when, for example, you've made a connection or dropped a connection. When you make this call, and I'll show you what it happens in another window, because okay, so here's an example of starting a capture. So this is running, it's actually capturing things right now. Now it's storing this in an ETL file. Now, there's a bunch of things in Windows that understand ETL files. GetWinEvent is one of them. And also, the message analyzer will let you load up this ETL file as well. Turns out that when you're using remote access, this will never stop, so I'm going to cancel this right now. And I did it, and there's one in the oven. Now, I'm going to use GetWinEvent to do this. The majority of the time that GetWinEvent spends is actually sort of parsing that big ETL file. It's really big, it's got a lot of data in it. And using the results from this, we can start to actually look at the actual packet capture data that we were getting. Now, take a look at this one. This is when I supplied my username to that remote server. Now, one of the nice things about Message Analyzer is that it lets you dig into this. So we did see the plain text, and that started to make sense. What you can do is start to open up and expand out these rows to see what do they mean at the different levels. So there's a concept called the OSI Layer Model, where it says, hey, the lowest layer is actually the physical connection between two things. Then you go above that, and it's like, well, how is the communication within that physical connection handled? And above that, then you have, well, how is the networking protocol within that? Then you have like TCP and application level. So there's generally considered like 7 of them. This lets you dig into each of those levels and say, well, what was actually being transferred at that point? Now let's take a look at how we do some of this from PowerShell, and then you'll see how it mirrors the stuff that Message Analyzer tells us. So, let's take a look at one of those packets we captured. So this is a packet fragment. So this isn't something that you do on a day-to-day basis, but if you're wanting to do some advanced network analysis using PowerShell, this is a great start. So this is a packet fragment. It's got properties. Now, the third property that you might wonder why that was blank is because of my screen sizing, but there's a bunch of properties with values. Now, the third property is actually the packet data. So there are some neat numbers. Now, what might you do with that? So you see here that there's a bunch of hex data, which is the more common way to represent network captures, which represented plain text ASCII going across the network and making a connection there. Now we talked about some of that crazy weird stuff that happened. We saw this in the capture, but there's a bunch of garbage that we saw that we couldn't figure out. But so let's take a look at that. And actually, here's a quick way to just take a look at what did you just capture. So this is all the text of the packet capture. This goes on for a while, but if you investigate it, you can see that, hey, some of this, while I was capturing, there were, my printer was attempting to connect to something, and my computer was talking to my Xbox to see what's your icon so that I can display you in the Explorer menu. So there's a lot of stuff happening in the background as you're just happily typing away. Now, so you see that number there, that magic number isn't too magic. That came from here. Now here's the packet before it. And it looks like some alien language, kind of helpful. Now let's take a look at the beginning of this. What does this mean? Now, there is that initial data actually comes from the very, very lowest layer in that stack, the Ethernet layer. So you've got actually two computers talking to each other, and all that matters at that level is, hey, I want to talk to this one guy. If you're listening, let me know. And then that is the way that messages are routed. Now, it turns out that these first 6 groups of numbers in this hex here, those first 6 represent the MAC address. You guys have heard about MAC addresses and all that kind of stuff. These first 6 represent the MAC address of the person I'm trying to talk to. Now, how is that helpful? Well, I can do select string 20-E5-2A on so the IEEE online has a registration database. So MAC addresses aren't just truly random. You end up being associated chunks of the MAC address range. So the first 3 words in these first 3 segments here represent the company that the MAC address has been assigned to, and the last 3 represent a unique one. So I was trying to communicate to a Netgear thing, so you might not be surprised that this was me at my house making a connection to my Netgear router. Now, those take up 6, like I mentioned. So then the next one was the next 3, O1F, BC. So I've got an EVGA motherboard on my computer, and that's where they got their MAC address. And it's not a very complicated thing. You can get this from the IEEE. And all it is a list of MAC prefixes and the company that was assigned it. So a bunch of interesting things. Now, that was cool. We got to find out some MAC addresses. Yep.
Could you just query their web page and get that text file so you're always current?
Yeah, it ends up being pretty dodgy.
Okay.
It was down a bunch when I was trying to get it recently. There's a bunch of websites that keep this text file and let you do it online. So you can use all kinds of methods to do that. But this database is kind of fun to have around.
Yeah. I don't know how many people know about dash context, or shell dash context for SLS.
So here's an example of showing with select string, you can actually get at the context and say, well, hey, who was given this MAC prefix before and after this EVGA corporation?
I was thinking it's 0, 4, because it gave the address of the. That tells you how many lines before the match and how many lines after. So there's the address.
So you can also use Delimiter as a fun way to break out records and stuff. But here's a great example of starting to do some advanced network stuff. So now you can imagine actually writing a PowerShell script to dig through a whole network trace, finding anything where I've got an Apple device. Where I've got an Apple device talking on my network. So you can do some pretty crazy stuff here. And it goes further, so we've got now you might wonder what these random ones do. If that MAC address thing was so fun, what might this do? So PowerShell has a great way to convert hex with OX. So I'm now pulling out that C0. Here's an A8 that I was wondering about. 01, 03. So those 4 chunks of hex up there represented the IP address that was making that request. And this was on my home network where my IP was 192.168.1.3. Now with that background, you can actually start to look at these different frames and say, well, hey, this TCP connection here is my source address, and then you can see what's highlighted here is those same 4 hex bytes that we just looked at. So this is the work behind what is required in making a network parser. So there's a bunch of good blogs out there. Manifestation has a great one about how to parse random binary data with PowerShell. So he's using it for binary analysis, but you can use some of those same techniques to start analyzing some of your network captures. So there's, kind of beginning to end, how you can go from top of the stack, dealing with IE, bring in the dev tools to get some more intelligence about what's being transmitted and why. Go off to Fiddler if you want to start messing around with those TCP things. Then you can keep on going down, send TCP request or direct TCP scripting to automate some of this experimentation. Then you can even go down, start automating packet captures, packet analysis, down to all the way to writing your own parser if you want. So, nice deep dive in networking. Any questions while we got some time? Yeah.
You invoke JavaScript using invoke web requests?
Yes, so invoke web request in IE. The IE engine hosted does have the ability to run JavaScript. But in general, if your main goal is automating a JavaScript-based application, right now the best of breed is really to automate IE itself.
So it's better to see what the JavaScript is doing and just mimic it as a regular HTTP request.
Yeah, right. So
Rather than invoking JavaScript.
yep, a lot of times what these JavaScript apps are doing is they're making requests out, getting data, putting it back, and so kind of getting it down a bit lower is the good one there.
Ladies and gentlemen, we're going to set up for the next couple of hours for our data. Everybody thank Lee Holmes.